Right, everybody, hello and welcome to InfraWorks and Civil 3D. We're going to be looking today at how we can prep a site using InfraWorks as a live demo. And then I'm going to hand over to my friends over here at RWO, and they're going to go through their workflow, how they then extract the information from InfraWorks and actually then start using it to produce a 3D design using Civil's 3D. So we're just going to do a brief introduction for ourselves. Myself, I'm Luke. I'm from Cadline itself. I've stepped in last minute. My colleague Trevor was actually supposed to be here, so he's off doing other things. So you've got my beautiful mug instead. A couple of apologies to start with then. Obviously he's not here and I am. And the other one is going to be their accent. So you're going to have to learn from the Geordies, I'm afraid. I've been a civil engineer working in industry for over 15 years now. I started off working for a consultant, quite a large one. I worked in local authority. I've been doing road design, roundabouts, civils projects for all that time. And now I teach and train at Cadline. So we're here today with Craig and Alex, and they'll introduce themselves.
Yep, my name's Craig Robson. Worked in the industry for over 15 years. Number of multidisciplinary consultants. Worked across the maritime sector, civils, structural. Over the last 4 years, settled into working mainly residential developments using AutoCAD Civil 3D.
I'm Alex. I've worked for RWO for over 2 years now as a senior design engineer. I run our North Yorkshire office. I've got over 12 years experience in engineering, working on a wide variety of developments, not just as a consultant but as a site engineer as well. In my time at RWO, I've been predominantly using Civil's 3D, and that's been helping us to carry out the detailed design, your section 38 and 278 highway agreements, your 104 and 185 legal agreements for the water authorities, and that's been for residential, commercial and industrial developments. But I've also used rival software packages at other consultants in the past.
Okay. What I want to do is just gauge who's had interaction then with InfraWorks as a standalone project, who's then used it to take that data and actually use it into Civil's 3D and use the extraction and the IMEX data transfer between the two pieces of software. So, very informal. Just to raise your hands, those who have actually used the InfraWorks software before. Okay, I was expecting most of you to put your hands up. Those who've used it in conjunction with actually doing a design or a process in InfraWorks and then actually extracting it and using it in Civil's 3D itself as well as to complete the design process. Okay, so not so many. So what we're going to do then is we're going to go through a few slides and we're going to talk about a few things, and then I'm going to do an on-the-fly demo. I'm going to bring some data into InfraWorks for you. I'm going to show you how we build up the model, how we get all the information and the data in. We're going to show you how we then actually import design control management systems. So we've got all the local authority data for density housing, building heights, and actually being able to actually restrict the site and the flooding analysis and things we can do with the surfaces around there. So I've just spieled for you exactly what's up on there for that. So we're going to step through. Once I've done my demo on the InfraWorks stuff, the RWR lads are going to go through and show you the actual processes they take through in their presentation. Craig's going to give you a brief introduction of what the site is, and then we're going to step in and I'll show you how we're going to build it up and how we get the information from InfraWorks to Civil's 3D. Over to you, bud.
Smashing. So the site itself is a residential site up in Medburn, outside of Newcastle. Looking at general considerations with the site, stuff you consider on any site, whether it's residential, commercial, industrial, topography of the site, drainage, boundary constraints, services, you know, is a site flat, steep, what are your drainage outfall points, boundary constraints, you know, access and egress services, any existing easements, drainage, any other services to consider, site investigation and environmental considerations. The site itself, what we're looking at through Civils, it's a 50 executive dwelling site over 4.4 hectares. It's part of a much larger site, what Luke will cover with his InfraWorks. Site was greenfield in nature and in a rural setting. Now, site-specific constraints, what we came across on this site was the existing drainage. There wasn't adequate cover. There was an amount of existing drainage, but the site had been developed previously on an ad hoc basis, plot for plot, around its perimeter, so it was a bit of a mix and match. There was a number of easements to consider. The topography of the site, it was all right, this one actually, it was a flat site. As you got towards the northern boundary, it sloped off steeply to a watercourse. Caused a little bit of a problem with an attenuation pond, what we had to fit in. You'll see that later on. Then boundary constraints to the site, fairly consistent throughout, backing onto residential properties. But the site access was too narrow to be adopted, so a couple of existing properties were purchased, demolished, and that was widened. Now I'll pass on to the larger site to Luke for his InfraWorks.
Okay. So we are going to go through, as I said, we're going to do an on-the-fly InfraWorks model build. There are going to be some presets already in the software to actually be able to download the large file type for the model we've got in here. With the shared Wi-Fi that everybody's using today would have been actually quite slow. But we are going to do some live cloud-based analysis, the flood module that we have in there as well. So we're going to go through, and as I said before, we've got a set of constraints for local authority buildings, so density controls, land use areas. So I'm going to show you how we can then actually extract that information and bring it into InfraWorks, apply what we call tags or asset IDs, get them to show within InfraWorks model itself, get them to color up by sending some rules through, and then we can also link to external documents, external websites, and alike for that. So we can actually build within the InfraWorks model itself a very detailed narrative of what's actually happening in and around the site and why we've made such design decisions. So we're going to go through and you'll see all the site build up and the existing constraints we've got in there. And eventually we'll end up with a 3D model that actually details up the plot of land that we're actually developing for this specific site itself. So I'm going to step into InfraWorks now, and as you see, it's preloaded, and this is the information we're starting with. Now, those of you who are quite familiar with InfraWorks know that you have a model builder itself based within the actual software. It's not as detailed as the one we're using. This has actually been constructed using a joint partnership with Cadline and Ordnance Survey, and this is our OS model builder. There is currently a giveaway on our stand, if you want to come and see us afterwards, where we are actually giving this away for free. You can actually come in and you can actually use the terrain data from Ordnance Survey. You can get all their data, their mapping, the building heights, the reefs, roads, rivers, everything you'd get from a typical 2D OS tile, but you can get it in a 3D format, and it actually comes through. It's just taken a little longer than I thought with the Wi-Fi, but it's basically, you come through, you've got yourself a map of the United Kingdom, which OS covers. You can navigate to wherever we are within the country. So we are doing Medburn, which is just up past Newcastle.
God's country.
It's not God's country, that's Shropshire. And you literally just select the areas you'd like to go to, zoom in on the areas, and then you can just select, process it through, and as you can see on the side, you get all the aerial photography, the buildings, the terrain, and everything else. The rivers and the roads are free modules which are additional, which you can add on, but this isn't a sales pitch, this is just purely showing you the data we've extracted from this website in order to actually construct our 3D model. So when we actually bring it into InfraWorks itself, it brings in all the buildings, it brings in all the design roads. We just then tailor it a little bit to actually get a more conceptual reality of what we've got around us. So there are tools within InfraWorks itself where we can come in and add points of interest. You'll see in here that we've already got some pylons that we've added in. You can see all the water courses that's coming from adding in the river module that we had from OS Model Builder. And then we've also got a selection of trees. And there are a multitude of different points of interest we can actually bring in through this site itself. What we do once we've constructed our main model or our master plan within InfraWorks itself is we then build from it. We don't ever copy over the top of it, and we build a selection of scenarios over the top. So you'll see on my model that I've got here at the moment, I've got a few set up already. So these are so we can actually edit the information we have on top without actually losing the raw data we have in there. So the first thing I'm going to step into and show you is just some of the terrain tools and things we can actually use coming through. So, where are we? We wanted trees. So let's put a, where are we, trees? Where's my points of interest? Sorry about this, I've just lost my button. Never mind, there we go. It's different on the screen. Usually when we set up on the projector screen, every button's just been compressed to the size and they're not where you want to see it. So, as I said, we have a selection of trees we can bring in. So we can bring these in one by one. We can bring them in as a multitude of rows. I said those of you who are most familiar with InfraWorks will probably have used the point of interest feature before. But we can just come in, and as I said, it's just a case of just tracing over where we have them before. Put it in. And flick around. And then you get all the multitude of controls, and we can click on them when we can change the height, we can change the progression, the actual foliage rates. So we can actually, as I said, get a build-up of the sites we've got in here. What I'm going to do just for this site itself, we can actually do a surface analysis similar to what we can see when we use a surface within Civils 3D itself. So I'm just going to switch to my terrain tools. So I've got terrain themes I can add and apply in here. So let's have a look at the height or the elevation of the road and the site around us. Let's just flick to a nice colour palette that we can use. And then you can see all the little gradient changes. And as Craig said, this is a fairly flat site, so we're not going to be seeing any of the large actual changes to the land orientation in this one itself. There are a couple of other themes you can add in. We have ones in here for aspects and slopes. The slope one, as it's been a very flat site, doesn't show too well, but we'll try and illustrate what we have over the top. So there you go, you can actually see the varying slope percentages and all the changes over the existing terrain itself. We typically do this just to see where it's more sociable to actually build the houses. We'll try and do a first instance where we try and reduce the amount of cut and fill we've got for the site. From that, we can then also do some point-to-point distances, and one of the ones I actually quite like. Craig mentioned that the site itself that we're going to be developing drops off quite severely to the back of the site itself. We're going to be eventually developing this field area here. If I drop on my slopes and just come over the top there, you can actually see how it severely drops off to the end, and then, as Craig mentioned, there is actually a river running off the back. We are not going to actually use the river itself for our output drainage. I think you built a pond at the bottom. So there's
Pond, but will eventually discharge to the water course.
Yeah. Okay. So, another analysis we can do over the top of this is actually using a third-party application that's added into the software itself. So I'm just going to flick to a flooding analysis. So the third-party software I'm currently using in this to run the analysis itself is a product called Hydronia. And it runs basically a cloud-based service. So you can go in and you can select the area you actually want to use. You can select the input for your water courses, select where it's going to discharge to, and then you can actually then run your analysis itself. So if I just step into there, and we will run an analysis. So our flood simulation. I did preload one just because I wasn't aware of how fast the internet speed was, so we will use this one. And all we do within the flood analysis itself, we specify the criteria, so the area we'd like to see, and it will process it in either a 1 in 10, 1 in 30, or 1 in 100-year storm, and you can actually see how it compares, so you see which land and things it floods up. It gives us a better understanding of which area of the site we can then deliver. So this one's set for 1 in 100. I'm just going to run the simulation because it's already preloaded. And basically, we set the input area where the water's going to come in at the top here, and then you can see down the bottom just where my green line is here. That's my discharge point for this site. And then once the animation's actually processed itself, we can then actually see it actually developing in the site, and you can see at the top and how it progresses. This one's currently set to the velocity, and if we zoom in, you can actually then see the velocity arrows and how it increases with the amount of water that's actually coming into the site. It's currently discharging in this one over the farmers' fields at the top. Within the same analysis, you can then also analyse the depth of the water that's coming into the site and the elevation of the final surface of the water once it's actually been discharged through the actual flooding scenario itself. It's getting very hot up here. Okay, so we've got initial design tools and planning where we can do analysis, but what we want to look at is how we can actually then develop this site specifically. And again, this is where it now comes back and we're linking in all of those control documents. So prior to this, we had all the various site constraints. We were actually given a site itself, all the different development plots that the multitude of actual independent developers are going to be using themselves. I'll just get rid of that. And as you can see, this one is currently pre-populated with a load of colours over here. Now this is a set of information we've actually extracted from the design plans we were given from the original architect themselves. What we've done with these is we extracted the lines and the polylines and we took them into Civils 3D and we used the map tool itself. And from there we've added in a SES conversion and we've added and combined the data from those preset documents. And it's been able to tell us which densities for each shape. So what I'm going to do, in fact, I'm just going to drop onto another one and I will show you that coming in itself. Let's go land use. And we'll show you the fact that we can actually bring in these. That's a bit better, no colours on here. Okay. So what we do is we bring in and we, Apologies for that. And we bring in some additional data. And as I said, these have actually now been pre-populated to an SDS format, and that's just included all the spatial data. And I'm just going to bring these in. So we've got our SDS files. And we've got our development area. When we bring it in, every time we need to bring it in, it's going to need to be configured for the grid system we're working in. This one should be set for our British National Grid, and then we just have to tell it what we'd actually like to do with the lines we brought in from the SDS file. So this one is just going to show us coverage areas, and I'm just going to add in a standard palette itself. And when I close and refresh this, you will then actually see the areas that we were given for our entire boundary for this site. Just checking on the time. Apologies, it's not doing what it wants to. That's what I want. There we go. Not whether you can see it very clearly on the screens themselves, there is actually a shape in there, and you can actually see the red line boundary that's now actually been produced for this site itself. So this is the boundary for the entire development itself, rather than just the one specific plot that we've got in here. We can customize this slightly further. We can go in and we can add in other SCS features and things we've got in there. We can go through, and as you saw on my other scenario, we can actually go through and we can color up. And what we do is we run what's known as a set of rules within the software itself. So we can come in and we can tell it that we'd like a certain tag or asset ID, so for high density, low density, or potential areas of flooding. We can then get them to highlight, and then as you can see, if I hover my mouse over the top of this, it actually displays what each of them are individually as well. In accordance with this as well, as I said, we can actually link into external documents, we can link to websites and everything else like that. So what I'm going to do is we're going to add one of those in as well. So if we select one of the areas we'd actually like to use, go into our properties for this actual area, and then we have what's known as the tooltip itself. And this is where we can actually then run and we can do links to external features. So in here I have a quick link to the actual National Grid set of standard documents. And this is where it tells us for things like working next to overhead power lines, underground apparatus. So we can actually come in here and we can actually do a direct link to the URL. So we can preview that. Update our model. And again, apologies, it might not be very quick due to the Wi-Fi that we're running off. But as you hover over it, you can briefly did see then the actual link to the URL. If you hover over there long enough, it will then actually produce a window within the document itself, and then you can actually see where you are in the URL, and then you have the option to then expand and actually come out of InfraWorks and into the actual Internet Explorer itself and actually go and explore the document. So we can use this for this larger element itself. We could link it directly to all the different house developers that we have throughout the site, go to their sales sites if that's where they wanted to go to. You could go and see all their different specific standards or the local authority standards that we actually have to build with itself. So we prep the site, and it just gives us a greater idea of where we are actually going to develop. So I'm just conscious of time, so I'm just going to move on and now actually show you how we can bring in some of the elements that we get from the architect's drawing, such as the centre lines of the roads, bring them through, and actually then start manipulating them within InfraWorks to prep the design and then get it ready for these guys to take over and actually do their detailed design in civils. So I'm just going to flick to my phase 1 plot itself. And as I said before, we are going to be developing this area of land over here. So the first thing I'm going to do for this one is I'm just going to bring in all the centre lines of the roads that we've got from the architect's drawing. Now, I've converted this into the IMX format itself. So this is the format that talks between Civils 3D and Autodesk itself, InfraWorks itself. And if I just switch to my site. In here, I've got my road alignments themselves as an IMX file. I'm going to bring those in, and then as I configure them, I'll tell the software that they're roads. I give them a generic style. I like Interstate Road 2. Bring those in, close and refresh, and then you'll see as they come in a second, these are all the roads that we've taken. So all I did to actually get this IMX and these alignments, I used the simple tool that's in Civils 3D itself. If you use the alignment drop down, I think it's the third button down, you've got the nice create from object. All I did, click on their polylines in sequence and just created 5 separate alignments themselves. And by bringing them in through the IMX itself, it's taken all the vertices and everything else from the software. Now, as Craig said in his introduction to the site itself, we can actually see that the access road that's designed for this site cuts through the 2 buildings. So there's going to be some demolition required. One of the nice things about the scenario is I can now delete these buildings out of this specific scenario and actually get rid of them completely so we have a through clear route for our site. What it hasn't done, it hasn't changed anything on any of my other scenarios themselves. So again, I can do multiple options. If you're going to be doing different road layouts and you have to take into consideration traffic counts and things like that, you width or length of the road, any times you've got to do, you can do this very, very quickly through this actual software itself. And it gets you into a nice state very early on. So it brings those advanced design decisions back down to very much to the prelim stage before you actually have to commit too much time and effort into actually doing a multitude of options. So I've brought in my road. It has come in as a design road itself, if I hover over it. It's come into a DMRB standard, because that's what we've got preset in this software. But I can easily convert it back to a component road. And once it's converted back to a component road, it then gives me control again over the vertices, and I knew that would happen. But the beauty of running InfraWorks, because it's all data-based, I just reopen it again and it'll pick up exactly where it's just left off. It's like me, it doesn't like the heat, I'm afraid. Once I've got it back to a component road, then, as I was saying, it then gives me functionality within the InfraWorks software to actually then adjust the alignment. It allows me to drag and connect it to another road. Doing so within the software, as you may know, will automatically create the junctions, again, in accordance with the DMRB that we've actually got preloaded. Let's just jump into there. Once we have the roads from our IMX in there, just while this is loading, we have the functionality to add all our drainage in. So, come into our site, let me just turn that display off. There's my rules. Just tick those off, don't need those showing at the second. As I was saying, now it's back to a component road. All the vertices are there for me to control. I can step it in if I wished. I can do a cut and fill calculation. So I can do the materials quantities, I can then kick out and actually then give myself a cut and fill report at this stage. But one of the nicest features, and especially on the early design stages when we're looking at developing this for a housing layout, is I can just right-hand click and immediately add a drainage network to it, which is then exportable into Civils 3D, which these guys can actually talk you through a little later. So all I'm going to do here is just quickly drop one in. It should generate the network for me. So this is going to place all my manholes, it's going to place all my gullies, and as you can see on the site, and all of the actual structures and pipe connections underneath themselves. Right. What we're going to do on this site as well is we can also bring in the plots. So we don't have to bring them in one by one. We can bring them in as a multitude. And again, this has been done through an SDS file. So I'm just going to bring that one in. So we'll bring the house plots in. And again, with any of the SDS files, we have to come through and configure them. So we're going to tell it which coverage area we're going to be using, and we'll just give it a generic style, and we'll close and refresh. The beauty of bringing them in like this as a coverage area means immediately we can actually start manipulating the levels that these are at. If you had a set of preset finished floor levels, if you're doing a large commercial area or a large supermarket which are fixed by the falls and things in and out of the property itself, you can link this SDF to a database. You can actually then have this come in and use that data automatically and fix every individual plot to those levels themselves. These ones we've got in though, we can just come in, select it, and we can actually do the right-hand click and shape it. So you can see on this one at the moment, I'm half in cut, half in fill. It's just a case of pulling it up. I can manually insert a level, or I can actually come round and actually type it in where I'd like to be. And it will blend all the surfaces for me as well. Once I'm at this stage, the most logical thing to do once I've got a standard pad in there is just to bring in a house, and let's bring in a detached one. Now these house models that we're using in this demonstration are from Revit, so they're not geo-referenced, there's no geolocation in here at all. So the easiest way for us to bring it into the model is just to purely stick it through interactive placement. And it's just a case of coming in, close refresh. What we've got here as well is there are scripts available for InfraWorks where if you are doing a multitude of houses, different types, and you don't want the same house on all the plots, again, you can link this SDF to that same database, just specify what plot number has what house style, and they will automatically come in and be placed in the center of each plot. The only thing it doesn't do, because they're not geo-referenced, is the fact that we then have to come in and manually rotate them just to fit. But you don't have to come through and actually specify each specific house for each plot. That can be done automatic for you. Once you're happy with your final model then in InfraWorks itself, we can do the logical thing. There's no point wasting time, so let's export it all the way out to Civils 3D and continue our actual detail design. And again, I've spoken about it before, we are just going to be using the IMX format itself, and we can just select which areas. It doesn't have to be the entire site. We can select a polygon, come through. If we wanted partial sites or the whole development itself, you can really customize it to what you need it to be. Send it out to IMX, and then when you enter into the Civils menu on the insert screen, you've got your InfraWorks tab immediately there in front of you. As you bring that in, you have full options to customize all your pipe networks. So if you wanted it to sewers for adoptions, you can have all their line type styles, all their sizings. You can change everything else through there for you. And that's where I'm going to leave you guys. I'm going to hand you off now to RWO, who are actually going to show you how they go through their own formatting themselves and get their sites ready for their clients.
Cheers. Thank you very much.
No worries.
So what we do now is we create our schematic design by importing the raw data that Luke's created within InfraWorks. This is again done through the IMX file. Within Civils, you can set up your own settings within your company of what information that you actually want to take out of InfraWorks, whether it be roads, existing proposed surfaces, the drainage, alignments, profiles, and you can set them up to your own layer and standards. For our schematic design, we use our own bespoke label set. We build out the roads, the sewers, we produce the long sections from the alignments that's previously been created within InfraWorks. We can carry out a strict proposed to existing cut and fill comparison, but we don't build our junctions out. You can do this within AutoCAD Civils 2018, but as there's not a UKE setting or standard set up yet, we're working within Civils 2017 for this presentation today. As mentioned previously, we've got our own bespoke template, which includes various labels, styles, and settings. These can easily be changed throughout the design to show what information that's required at each specific stage. So basically, there's no abortive work from InfraWorks to Civils itself. So at RWO, we work with this file structure that you can now see with on the screen. We've got our WIP, which is our work in progress folder. This is where all our designs that are currently being worked through are stored. We've got so you've got your DR, which is your drawn folder, which is all your data sheets, plans, layouts. You've got your export folder, which is the information from Civils that's exported to AutoCAD itself. We've got our M2 folder, which is all our 2D data, which is, in theory, your XREFs, your architect's layout, your topographical surveys, any other third-party information. You've got your M3 folder structure, which is all your 3D design, which is all your Civils files that will create your multitude of data shortcuts. So you've got your alignments, profiles, corridors, you might have your existing surface, you've got your drainage. Any other information that's created within Civils is stored within this folder. And you've got your WIP TSA, which is your work in progress temporary shared folder. So say if you've got a query within the development with the developer or for the client or third party, we'll put our M3 file in that to talk through the developer with prior to actually formally issuing the document or file. We've got our shared folder, which is when we finally share our 3D files. We've got our published folder, which is when it's formally issued for tender, construction, schematic stages. Then you've got your archived folder, which is for any superseded designs, as most developers change the layout for 2, 3, maybe 4 or 5 times. So basically, with creating a schematic, we're taking our M2 files, which is our third-party sources, 2D drawings, which is your site layout, OS map, topographical survey, your M3 files from InfraWorks. So from InfraWorks, we're generating our alignments. You can generate your profiles, your drainage, as previously discussed. So we've got our drainage M3 civils. We've got our alignments and profiles M3 file, which is created and detailed up in the civils. And we've got our existing and proposed services. From these, you're getting your XREFs from your M2 files, you're getting your data shortcuts from your M3 files, and then we're creating our DR files, which is our end product. So we apply our schematic label styles. At RWO, we've got label styles set for each set of construction stages. So you've got your schematic, tender, construction, as built. Right. Once we've created the files, we'll issue them to the client. We'll get the approval, make sure that they're happy prior to us actually starting the detailed design, to ensure that they don't want any further tweaks or any minor changes to the layout itself. Yeah. Right, I'm going to hand you over to Craig now for the detailed design.
Right, as Alex mentioned there, we've got our file structure, and one of the folders in there is M3s. Now, typically on any job, any residential job, we'll have 3 core M3 files. We found with the workflow we've developed over the past years is that we split them up into an M3 for your alignments, profiles, and corridors. That keeps all the road design data nice and neat together. We'll have another M3 for drainage. These two are data shortcutted together, so they read information from each other. Then they come together to form a composite M3 surface, what we can then extract data from through labels and label sets to produce our final drawings. There is other M3s we can produce depending on what the client or site requirements are. Cut and fills, strata sets if there's any rockhead running sand on site, any ponds, attenuation structures, landscape features. They can all be brought into the composite surface later on. Now what we'll do now is touch on to each of them 3 core composite the core M3 models. The first one, what we'll typically look at, is the alignments, profiles and corridors. As we had no abortive work coming out of InfraWorks into Civil 3D, we'll have no abortive work from our schematic stage onto detailed design. We'll just take what we have and build it out further. So for those of you who've used Civil 3D, you'll know about assemblies. We take the assemblies, put additional detail on them. We build our junctions out further at this stage. We're doing it at the schematic stage because, as you'll know, developers like to change things a lot. And it takes a lot of time to rebuild. So we don't do that till we go into detailed design stage. We'll build out any features, visit our parking bays, raise tables, anything like that, and apply our detailed label sets to get drawings from there. Now what I'll do now, if I can get this video to play, I'm not as brave as Luke, so I'm not doing a live show, but I've put a little video together of one of our models. This is M3, again, alignments, profiles and corridors. And when the drone kicks off, it should zoom into a little section. You'll see where I've built the VP out around the junction area. Just going into that now. So for those of you who are familiar with Civil 3D, you'll see we have a corridor stretching out there. It's split into a couple of regions, one over the bell mouth of the junction. We're going to go into the corridor properties box here. You can see the selected regions are highlighting on screen. We're going to look at this particular region where the visitor parking bay is. And what we're going to do is use some polylines there to target to the back of that visitor parking bay. You can target from either side of your corridor. What we're doing, just selecting the lines from the drone there. It's not just VPs you can target to, you can target to any feature build-outs, what the planners require. There's a multitude of things. See how I've selected them 2 lanes there. And when we rebuild the corridor here, you should see that jump out to include the visitor parking bay. Just taking a little way to rebuild there. There you are. I know it doesn't seem, you know, visitor parking bay is like it's a great detailed point of the design, but you can take all setting out information, everything from this. What we're looking at here is we're just turning the surfacing on. So you can see you've got all your road corridors in there. Again, as I mentioned, this is a composite corridor surface, so when we go into the object viewer, we can take it and zoom around the site, and you can see all your roads are fully built out in 3D. And that's to a detailed design standard where you could take setting out and detail level information from there. To do that, it's just a case of applying label sets and styles for the relevant information you want. It's a little area there where there's a parking bay opposite a junction there. They're difficult to build out, so I'm not showing you that. I think that's it. Pass you over back to Alex.
Which one is it? That one. We're going back on. All right, so now we're going to talk about the detailed drainage design. So for the drainage on this development and for our workflows, we import the previously set up data shortcuts that Craig's just ran through, your alignments, profiles, and corridors. We'd also import the existing topographical survey. As mentioned again previously, we've got our own bespoke civil 3D template with our own drainage styles, labels, parts, which all correspond with all the various different water authorities. There's one set up for each. And this eases the process of getting the drainage adopted and the approval for the developer. In the model, in the video that you're going to see shortly, we've basically applied a detailed label set to the drainage. This is your manual references, your covers, your invert levels. You've got your pipe nodes, which reflect the information within microdrainage itself. As many of you are probably going to be well aware, within 2017, there isn't a fix yet between microdrainage and Civil's 2017. So you've got your pipe nodes, you've got your lengths, you've got your diameter of pipes, you've got your gradients, your impermeable area from your catchment areas that are affecting that specific pipe itself or manhole. However, you can apply separate label sets if you want to strip back that amount of information. You might have a busy drawing, or you might need to reflect a certain design stage where you're currently working at. Once the network has been created, we check for clashes using the built-in interference check. Once we've checked everything's working fine, we can now generate a dynamic manhole schedule and project the drainage onto the profiles that have previously been created, which you're going to see in the video in a minute. How do I get this to play? Is it going to work? No. Ah, it's working now. So here you're going to see a plan view. You'll see the long sections, the profiles, and the manhole schedules of the surface, the proposed surface and foul water on this development. And we're going to show you how dynamic the drainage is. Is it going to start working? Might need Luke's help here. It's working up there.
About 20 seconds because Craig's got a nice long intro in.
Sorry about that, guys. So now we're going to zoom in on this specific drainage, and we're going to show you how dynamic the drainage is. So we're going to zoom into the profile where we're going to move this manhole, and the same on the manhole schedule itself. Hopefully everybody can see this clearly. We're going to drag this manhole ever so slightly. There might be a constraint within the road, there might be some services that you want to avoid. And as you can see on your profile and in the manhole schedule, everything's updating. So the drainage is fully dynamic, and this removes the human error that most engineers typically encounter working on large residential or commercial industrial developments. And I'm going to hand you back over to Craig to talk about the composite M3 surface.
Cheers. So what we've touched on there with the last few slides is we've looked at our roads, alignments and profiles and our drainage. Now we're looking at the composite surface where we'll start building out plot works further. We did have finished floor levels in there, what came over from InfraWorks and what we had at the schematic stage. But we'll look to drill into them a little bit further, put exposed brickwork, flag on edges, any retainers, level access, stuff like that in there. As I said, this is a composite of the drainage, roads and plot works, but there is other M3s you could bring into this composite surface, which we touched on before, rockhead levels, suds, anything like that. So again, we've just got a little video set up here. Escape, is it? That didn't work. Sorry again, guys, I can't seem to get this to go.
You got your nice 20 seconds.
Yeah, just leave it, leave it 20 seconds. Smashing. So what we're doing here, we're just zooming into the proposed surface here. You can see the plot works, all our contours are on there. Any label what you see here with information, it's all dynamic. Go into the object viewer, scroll around, you can see that your pond's built down to what looks like the western boundary, there's a northern. You've got all your plots in there, your roads. They've got a 150 step down, which you would typically get around your plots, apart from the fronts, which have got level access. Apart from this plot here, which we're now going to build out, show you how we'll build that out a bit further. Just use standard offset tool in civils, take the feature line, offset at a distance, horizontally and vertically what we want, so that's your 150 step down. If we add that to the surface as a break line, you see once this is added, the contours will change slightly. Just seeing them change there. Go back into object viewer, and you'll see that that plot now has its 150 step down around the property. This means any drainage what we'll put in there is another M3, all your cover levels, everything are exactly as they would be. There's no interpolation, manual interpolation. One thing we're looking at here with this gradient is the fact that the back garden slopes off steeply. Developers, clients don't want to see this. We know on this development that we're happy with about a 1 in 30 gradient, I think. 1 in 25. Yeah, it's 1 in 30, so I've stretched the dynamic arrow out to that. And what I'm going to do is just show you how we'll put a simple retaining wall in the back garden, little flag on edge to remove that steep slope there. So we're just adding a feature line. These are just like 3D polylines with a bit of data for those of you who haven't used civils. Select the level where we're starting from. Run it back out to the end of that label where we had our 1 in 30. Select the surface level there, and then we'll bring that feature line back to the gable end of the property. give that a level, run it along to the other side of the property, and then we'll actually have a little bit of a private drive here, what needs retaining as well, so we're just going to step that feature line around the side of the private drive, try and get away from that 1 and 3 gradient, which 1 and 2 gradient there, which is a bit steep really for a landscape area. Just entering another level there on the feature line, then we'll bring that just to tie back in with the proposed surface. Again, we're showing a feature line for a retaining wall here. You can use feature lines to build any amount of features on your proposed surface. We'll just add that to the surface as a break line here. And again, you've seen the contours change there automatically. The gradients have changed. We're now down to a 1 and 3, 1 and 5 slope instead of a 1 and 2, 1 and 3, just with the introduction of a little bit of a retainer and some exposed brickwork to the gable of the property. If we go into the object viewer here, you can see that the side of that property now has a retaining wall down there, bit of exposed brickwork on the side and a flag on edge to the back. And that's all there with 3D contours and labels. You can put setting out information on there, issue that straight out to the contractor. You see the other features were built in there, the pond and any wetland areas. Sound a bit pan around the side. I think that's it for a bit of plot build out there. Pass back over to Alex.
So basically, what we've got now is our detailed design. So you've got your M2, your external references. You've got your M3 files, your civils files, your data shortcuts. And we use that to produce our detailed design drawing pack. So at RWO Associates, we've got a standard drawing pack produced at each stage of the design. The detailed drawing pack typically consists of your engineering layouts. So that's basically all your levels design, all your drainage design, all your plot works. There's a separate label set that's applied to the engineering layout, which reduces the amount of information that's typically shown, so the drawing's a lot more readable, so it's less busy. You've got your levels drawings, which is your finished floor levels, your threshold levels, your roads, backup footpaths, any other information that you might need to show there. Your drainage drawings is typically your drainage plans, your adoptable drainage, your plot work drainage, which is all built within Civils 3D. You've got your manual schedules, impermeable area, catchment plans, any other information regarding SUDs that you might want to show or the developer might require. You've got your long sections, which is your road alignments, which could have your projected drainage on them, but if your drainage is off-site, it will just be typically your drainage alignments projected on. We've got our road setting out. This is just produced with another label set with a click of a button. Within the alignments, profiles, and corridors M3 file, we can quickly change everything, and there's a full pack of setting out there ready for the developer, saving them some time. We've got our curbs and surfacing. We're currently doing this as M2 2D data at present, but within Civils, if you've got the settings set up correctly, you can create or set up your different corridor surface styles to show the relevant covers for your adoption plans or the materials that you're planning on using. You've got your earthworks file, drawings, which is typically your cut and fills. It can be a strict surface comparison. It could be construction build-ups. It could be phased plans, depending on how big the development is. You've got your construction details, which is for, say, your water authorities for your 38278s. You've got your highway agreements. Then we've got our miscellaneous information, which could be anything else. It could be a flood route and information that's taken out of InfraWorks and set up within your drawn plans and sheets within Civils, ready for a shoot. So, in summary, we've done the site overview in InfraWorks. We've produced an overall analysis of the development, and we've taken that information out of InfraWorks, and that's assisted us in carrying out the schematic design. So this minimizes any abortive works, And this can be taken further forward throughout the design as just seen throughout this presentation. And it helps us produce our typical drawing pack as what you've seen on the last slide. So that brings us to the end of this presentation. I don't know if anybody's got any questions that they would like to ask or any specific questions. You can always find us over at the Cadline stand throughout the rest of the day.
Yeah, we are immediately across the hall. Go through the doors immediately on the left. You can't miss us. We're going to be there. If there is any information you want to come and ask us about, or all of this data is actually going to be available through AU themselves anyway. So you're going to have all the property sets, all the data I've used for the InfraWorks, or the whole PowerPoint presentation, or if you want to come and talk to RWO about their processes or anything at all, we are going to be there for the majority of the afternoon now. So thank you very much for coming and seeing our presentation. And if you've go on.
One quick question. Once you put all that into InfraWorks, how successfully do you manage to get it into Navisworks? Do you find
So the question there was, how easy is it to go from InfraWorks into Navisworks? Directly, not very, because it doesn't talk. What we do is we take the IMX file out of InfraWorks itself. We then push it through to Civils 3D itself, where we do the continuation of the design, and then we use the Navis exporter tool, that's the add-on, and we do a command called an NWC out. So we isolate all the features and all the actual items we want to move. We can do surface objects, we can do parts, we can do all pipe networks, everything else like that. Use the NWC out command. It will then create an NWC file which you can then append to a Navisworks model. You can then do your clash detection. So it's essentially a second stage from towing InfraWorks to Civils, and then keep using Civils itself to use that command and push it through to Navisworks where you can do your full detection. No worries?
This kind of development, I have seen lots of drop curve, transition curves happening to the drivers and the entry to the plots. Being a Civil 3D user, I didn't find it quite useful to design this transition curves.
Yeah.
It's quite good to do the full height curve or the drop curve, but doing the transition is not happening. So do you have any way out for that?
Yeah, I personally have my own workflow. I used to work for a local authority where we did drop curbs every day. So the easiest way to do is, once you've created your corridor itself, there's no need really, if you're going to be using a typical assembly, unless you're doing a junction, to change that. What we can do is, when you select your corridor, you can go into the section editor, and it opens up the view where you get your plan, your profile, and the actual cross-section you're currently at. If you then step to the position you'd like to actually start the lower part of the curve, so not the top itself, you can actually go in, and if you're using the UK country kit, you can actually then override that curb type specific. So if you're using a HP2, for example, you can go straight in, you can then change that to a bullnose curb, 6mm lip on there, and then you can use apply to a chainage range, tell it how far you'd like it to go, and then update the corridor model. If you lower the frequencies of your corridor down to meter, which is just above the curb height itself, the software will transition from your full height HP2 all the way down to your bullnose. And the only additional thing you have to do then is create a polyline or a feature line that retains the existing back of footpath so you can maintain that vertical line. And that's, from my experience, the easiest way of actually doing that itself. And that can then be additionally controlled within the corridor parameters tab. And then you can actually turn the overrides on and off. So if you want to do it very quickly, apply it for a long section, and then just go and untick the places where you want full height curves to be resurrected. Okay? At the front.
So you're saying micro drainage in out is only in the 2016 civil code, is that right? You can't get it across with the CSV file. So you take the, well, Luke will tell you better, but you take the civils design or InfraWorks design into civils, then you extract the CSV file, what you import into micro drainage, and then that can go back into civils. But there's no direct link because it's a catalogue part, isn't it?
With 2017, there was an issue with the country kit. So it was very difficult to go directly using the productivity tool for micro drainage. We are waiting imminently, I'm looking at the AutoGuess guys because it's due any time now, for the 2018 country kit, and the reason that's on hold at the moment is they're looking to fix that. So with the 18 edition, that link should be fixed, so you should be able to use the direct link between Civils 3D and micro drainage itself. Well guys, it's very, very hot in here. There's 3 seconds to spare, so thank you very much for your time. Go and grab yourself a cold drink.